Now that we've had an introduction to logarithms, we're going to go ahead and do some properties with logs. Eventually, we're going to use these to actually help solve some more complicated logarithmic expressions and equations. So we've already kind of talked about when the natural log of e is 1 and log base 10 of 10 is 1. Those are kind of that identity or inverse property. So today we're going to start talking about the product rule, the quotient rule, and a few inverse rules. So the product rule is if I have a logarithm, if I have log base a of m, and I'm adding it to log same base a of n. The product rule tells me if I have the sum of two logs with the same base, I can rewrite that as log base a of m times n. Similarly, the quotient rule works about the same way. We have log base a of m minus log base a of n. And then having quotient in the title, we should know that we're dividing here. So log base a of m divided by n. Now the power rule works a little bit differently. That says if I have a log base a of something raised to another power, so m raised to the power n, I can take that power and write it in front of the logarithm. So I can have n times the logarithm base a of m. Now all of these properties actually work backwards as well, and we're going to see that in a little bit. So first, let's go through these first examples here. We have log base 2 of 3 plus log base 2 of 10. Well, if I'm adding here, that's going to tell me that I'm using the product rule. I got that because I'm adding. So rewrite it log base 2 of 3 times 10, which ends up being log base 2 of 30. And then that is what we reduced to. All of these properties also apply to the natural log. So if I'm adding these, again, I'm using the product rule. So now I have the natural log of the square root of 5 times square root 2. Now you don't have to write them in parentheses next to each other. You can just put a multiplication sign between them. Multiplying like roots, I get natural log of the square root of 10. Example 3 and 4, now we're going to go through and we're going to go with the quotient rule. So here we have minus. That tells me, hey, I'm using quotients. So I have log, same base, 3 of 16 divided by 2. And I reduce that to log base 3 of 8. Same thing with natural logs. Can do it again. So natural log of x to the 5th divided by x squared. Now we have to recall we have two variables of the same base. We can subtract the exponents. So natural log of x to the 3rd power. And finally, we're going to use the product rule here, or power rule. So I have a power. If you ever see a power, you should say, hey, I can rewrite that down in front of the logarithm. So literally, it is 5 log, no base, so it's 10 of 3. 6 is a little bit tricky. There doesn't seem to be a power. There's no adding or subtracting. You need to recognize that this means 1/2 power. So this is the same thing as log of 5 to the 1/2. Again, bring the exponent down. You get 1/2 log of 5. Now you may be saying like, hey, Mr. Millikan, there's a power we left in this one. It said completely simplify or condense. You would need to bring that down. So this also can be 3 natural log of x. Same thing going back up here. I can go here and say, hey, this is 1/2 natural log of 10. You're going to have some problems that say, hey, rewrite the following logarithm using log base 4 and log base 3, or it could be log base 5 and log base 10. That just means, hey, look at here and say, how could I rewrite this logarithm using 4 and 3? Well, hopefully you realize 12 is 3 times 4. Well, that's that product rule. If it's a product, remember that you're going to add two logarithms together. So I have log of 3 times 4, which will then break up and be log of 3 plus log of 4. 8's a little bit tricky. You're going to be tempted to say, hey, 9 is 3 times 3. You can, but it's not the neatest way to write it. You should rewrite it as 3 squared. And then you have that power rule going on. Division tells me, hey, I'm using a quotient, so I'm going to have to do some subtraction. And again, this is that power rule. So now splitting this up, I have log of 3 squared minus log of 4. And again, take your 2 power, bring it on down. So you have 2 log 3 minus log of 4. Right? Now we have just 2 last properties. We have inverse properties if log base A of A raised to some power m. This is like when we talked about base 10 of 10. And then the power rule, hey, it says come on down. So it really ends up being m. Again, with 2, our second one is A raised to a logarithm base A of m. Similarly to this one, we're going to have m as the answer. So here I see, hey, log base 4 of 4. That goes away. The 7 comes on down. So really I'm just left with 7 as the answer. Because I could write this as 7 log 4 of 4. Here, remember that the base of natural log is actually e. So that's that inverse property up here. We're going to be left with just 10. Now, after watching this video, you should do number 1 through 10 on the properties worksheet that was handed out in class. And bring that to class to discuss.